It's another technique of investment appraisal. Okay, so what this internal rate of return is basically telling us, just giving us the annual rate of return for our project. Okay, colleagues, the annual rate of return for your project. Okay, then the other definition is this is the rate that makes the net present value 0. Okay, so when you mean that it's the rate that makes the net present value 0, it means the project earns exactly the same rate as the discount rate used. Okay, so the discount rate that you're going to be using, that's going to be like your internal rate of return. So those are the two ways you can look at it. So we're going to see now how we apply the internal rate of return. Okay, so we've got two machines we want to invest in. All right, we've got the alpha model and we have the beta model. All right, and we've been given the cost for each model. Okay, so we're going to use the internal rate of return to decide what to invest in. So this is the decision rule for the internal rate of return. If your internal rate of return is greater than your cost of capital, meaning the return of your project is greater than what it costed you to finance the project, accept the project. Okay. But if your internal rate of return is less than your cost of capital, meaning the return that you're getting from your project is less than the cost of financing your project, then you reject. Right? Colleagues, remember, cost of capital is just the cost of financing the project. Okay, so reject the project. Right? So this technique is just like an extension of the net present value technique. All right, let me just take all this information to Excel. So as always, I will do for alpha model, then as a class you will do for the beta model. Okay, so that as we move, we are learning. Okay, so we're going to use the internal rate of return to evaluate alpha model. So you make a table like this. You've got your year, you've got your cash flow, you've got your discount factor. Okay, the discount factor, we'll have to see what discount rate are we using. The discount rate that you'll be using is your cost of capital. Okay, your cost of capital will be your discount rate. In this question here, the trader's cost of capital is 10%. So that is your discounter rate. Okay, so it's a discount factor at 10%. Colleagues, these are the discount factors here. Okay, these are the ones. Then the discount rate is the 10%. Okay, then here you have your present value. Okay, remember, all that we're doing here is just using the same formula for present value. Present value PV equals your future value, which are these cash flows we're going to be receiving if we buy this model. Okay, if we buy the alpha model, year 1 we expect to make 200,000, year 2 180,000, year 3 160,000, and so on. Then in year 6 we can resell this model for 40,000. So all this information I'm circling in pink, these are your future values. Okay, you're going to convert them into the present value. Okay, so so you're going to put the years. You start with year 0, which is the first day of year 1. Okay, you're assuming the first day of year 1 you're going to purchase this alpha model for 600,000. Okay, so you're going to put under cash flows here negative 600. Why it's negative? Because you're purchasing this model. Okay, this discount factor is the 1 plus r to the power negative t. Okay, this is there, then this is there. Alright, so our rate is 10%, and since we're in year 0, so anything raised to the power 0 is always 1. Okay, so your discount factor for year 0 is 1. Any questions on that, colleagues? No magic done here. Okay. Yes. Any questions? Are we okay with how this discount factor of 1 has come?
So just repeat it again. Some of us are lost. We missed the other class for this.
So you are in for net present value. You are there. You never missed. You are answering.
Okay, sir.
Participating. So,
okay.
What I'm saying is this, you see this 1 plus r?
Oh, yes, okay, I see, sir, I see.
Our rate is 10%, right?
Yes.
1.1 to the power negative 0 is 1, right?
Yes, sir.
That's how the 1 has come about here. Okay. So the present value, you just multiply these two things here. Okay, negative 600 times 1, negative 600. Okay. Then now we get our cash flows. So as you can see, it's the same like the net present value technique, right? It's just like the same, okay? Once you've understood the net present value technique, then you would have also grasped this technique, okay? Okay, so for the discount factors, I'll go to the table, all right, colleagues? Okay, year 0 is not on the table, that's why you saw me do that, okay? Our rate, discount rate, is 10%. Okay, so these are our discount factors. Year 1, 0.909. Year 2, 0.826. if you don't have the table, you just be doing this tabulation: 1.1 to the power negative 1, 1.1 to the power negative 2, okay, for each year. Okay, that's if you don't have access to the table. Year 3, 0.751. Let's see, the 0.751. Year 4, 0.683. Year 5, 0.621. Okay. Year 6, 0.564. 0.564. Again for the scrap value. If we want for the scrap value, we can just add 40 plus 100, since both are in year 6. Okay. So you can just add them, okay, so that you have 140. So we can just leave it like this. Okay, there will be no harm done. Yes. Colleagues, are we okay with that? How I was getting these values from the table? Any questions? Okay, so we start getting the present values. Okay, 200 times 0.909, 180 multiplied by 0.826, 160 multiplied by 0.751, 140 multiplied by 0.683. Okay, each cash flow multiplied by the discount factor. Okay. Okay. Any questions? Okay, so the next thing, now you get the net present value, meaning you just add all of these up. Okay, negative 600 plus 188.1, let me just put it like this. Negative 600 plus 181.8 plus 148.6 plus 120.16 plus 95.6 plus this plus that, you get 99.74. Okay, that is phase 1. Any questions, colleagues? We have done phase 1. Okay, we found our net present value. First net present value. Forgot to mention, in this technique, you're going to have to get 2 net present values. Okay, you're going to have to get 2 net present values. One should be positive and one should be negative. Okay, so any questions, colleagues, so far before we you now get the negative net present value.
Just a clarification on the cash flow here. This one is provided for. The cash flow here, negative 600 coming down this side.
Yes, these are provided for. These are provided for. Okay. They are provided for on a good day. On a bad day, you have to tabulate these for yourselves. Okay, they'll combine, they'll give you information, then you have to calculate these cash flows for yourselves. Okay. That's on the bad.
So they'll give you they give you the present value,
No,
and then they will not give you they'll.
No, they'll just give you information about fixed costs, direct costs, and you have to get the profits, your expected profits. Those expected profits will be your future cash flows. Yes. It was done, they brought a question like that in 2022, and about 200 students repeated this course.
Yes, sir. That is that's dangerous. I think we need to learn that. We need to learn how to tabulate this because I can just imagine Mr. Boniface here.
I will show you, do not worry, okay? I will show you everything.
No, there's also a hand for Mr. Foster.
Mr. Foster, how may you can ask your question?
So I don't know if it's a question. I'm failing to connect. Why the question? Because I'm just seeing you tabulating. I don't know which question we are answering.
Okay, sir. This is the question here. Okay, we've got two machines we're looking at: the alpha model and the beta model. Okay, alpha model or the beta model. So we want to see which investment is going to give us better returns. Okay. So we're using the internal rate of return technique. Okay, Mr. Foster? We're using the internal rate of return technique, which just gives you your annual rate for your project. Okay, colleagues? Just remember it as that. You make life easy. Okay? It's just think of it as the annual rate of return from the project. Okay? So we go to phase 2. Okay, where we now need, since we've got a positive net present value, we need to acquire a negative net present value. Okay, with this technique, you're always going to have to get two present values, one positive, one negative. So remember this point, colleagues. Okay, if your first net present value is positive, let me write this down. If your first net present value is positive, increase the discount rate so that you get a negative NPV. Okay, colleagues? When you tabulate and you find your first net present value is positive, like in this case, we now need to increase our discount rate. Okay, so here you have to think of a discount rate greater than 10%. Okay, so it's up to you to choose. Okay, so you can just select any discount rate. So in this case, I'll use the discount rate of 20%. Okay, I'll use a discount rate of 20%. You can also use a discount rate of 30%, 40%, 50%, any discount rate, anything above 10%.
12.5.
Yes, if you want 12.5, okay, but what I advise, if you have the opportunity, choose a discount rate which you find on the table so you make your life easy. Because if you go above 20%, meaning you now have to start tabulating the formulae, that 1 plus r to the power negative t, you have to start doing it manually. Okay, and you don't want to do that manually, you want to just use the table and get your values. Okay, so I'm using a discount rate of 20%. Okay, colleagues, I have chosen 20%. You are free to choose any amount. Okay, so in the exam, if you don't want to waste time, I always advise be extravagant. Okay, choose a very high discount rate so that you get what you are looking for. Because what will happen is, if you choose maybe 11% and it still gives a positive net present value, you need to redo the process again until you get a negative one. Okay, so in the exam, be extravagant so that you are not spending hours on this question. So since I'm using a discount rate of 20%, okay, our discount factor, so now this becomes 1, this 1 plus r, which was 1 plus 0.1, becomes 1 plus 0.2 to represent the 20% we're using. 1 plus 0.2, okay, to the power negative 0 will always give us 1. Madam Karen, how many accounts do you have? Okay, so here it's always going to be 1. Okay, 1. Same as always. Okay. Then go to our table. Here is 20%. Okay, so let me just get that to the Excel. So here our discount rate, 20% is our discount factor. So for year 1, 0.833, year 2, 0.694, year 3, 0.579, year 4, 0.482, year 5, 0.402, year 6, 0.335. Okay, colleagues, just do that and you repeat the process again. Okay, remember, with the internal rate of return, you just want 2 net present values. Okay, so you're multiplying these cash flows. The cash flows still stay the same, okay, but you're now multiplying them with these discount factors for 20%. Okay. So year 0 is always going to stay the same, negative 600 times 1, negative 600. Year 1, 200 multiplied by 0.833, 180 multiplied by 0.694, 160 multiplied by 0.579, okay, and the process continues. Okay. So you tabulate your next net present value, okay, hoping that you get a negative one. Because if we get another positive one, we need to increase our discount rate further. Okay. Yes, we got a negative net present value, which is negative 53.22. Okay. Any questions before we move further? Okay, then we go to the interesting part. We now put this in our formula. Okay, so this is the formula for the NPV. Okay, so let me just write it in plain English so that you remember it. Do not worry, this formula will be provided to you in the exams. Okay. Just remember what it means. This 8% is the lower discount rate. That this NPVA is the net present value with the lower discount rate. Okay, net present value with lower discount rate divided by NPVA, net present value with lower discount rate, minus net present value with higher discount rate. NPV, lower rate, minus NPV, higher rate. Okay, then open brackets, higher discount rate minus lower discount rate. Okay, colleagues, this is the formula. So we're going to calculate now our internal rate of return. The lower discount rate is 10%. Okay. The net present value with the lower discount rate. So when we used 10%, the net present value that we got was this 99.74. Okay. When we use the discount rate of 10%, we got 99.74 as our net present value. Okay, so we say 99.74 over the net present value with the lower rate 99.74 minus the net present value with the higher rate. This second net present value that we got, negative 53.22. Negative 53.2. Right? Close brackets. The higher discount rate, 20%, minus the lower discount rate, 10%. So we start solving. Okay, remember order of operations. Okay, order of operations. So 99.74 minus negative 53.2, remember, negative and negative make positive. Okay, so it becomes 99.74 plus 53.2. 20% minus 10%, 10%. $99.74 plus 53.2.
53.22, sir. Or we just ignore the other two?
Oh, it was 2. Okay, no, we can add the other two. $99.74 plus 53.22, 152.96. Okay, this is how you show your workings in the exam. When they said show all steps, this is what they mean, show all steps. Okay, 152.96. Then 152.96 divided by 99.74, 99.74 divided by 152.96, you get 0.652. Okay, multiplied by 10%. So why aren't you converting the percentages into decimal numbers so that you just get your answer as a percentage? Okay, colleagues? That's why I'm not. If we can convert them into decimals, okay?
Yeah, I need to ask, is it why aren't we converting?
Yes, I always anticipate your questions. Okay? Even that formula, someone was about to ask, are we given? I already said it's already given. Okay? So I anticipate your questions, colleagues, all right? 0.652 times 10%, 6.52%. Okay. 10 plus 6.52%, 16.52%. Okay. So this is the return that this model is generating. Okay. 16.52%. That is your return if you invest in this model. So now we go to our decision. Okay, remember, if the internal rate of return, if the IRR is greater than the cost of capital is 10%, you accept the project. Okay, 16.52% is greater than the cost of capital, So your return is greater than your cost of financing. Okay. So here, 10% cost of capital. Okay. So if we were just looking at this model by itself, we would have said buy this model. Okay. But since we're comparing it with another model, you need to also see the other model's internal rate of return, and you'll see which model will give you a higher